Hi, my name is Daniel Ratai. I am the CTO of Parandrumi, and I'm here to tell you about our journey. So basically, my story starts in kindergarten. Then was the time when first I was dreaming about how cool it would be if I could draw in a 3D space. There was this cartoon character who is from the Polish cartoon movie Magic Pencil, and he had a pencil with which whatever he could draw, it became reality. And that was the first time when I was also dreaming about how magical that would be if I could also own such kind of a pencil where where if I just draw something, it becomes reality. And after that, in high school, I also had a dream. I was dreaming about becoming a car designer. And I remember that when I was drawing cars to the flat paper, I always somehow miss the proportions or just not what I really imagined come out to the paper. So that was the time when I was also dreaming about having a magical pencil which can draw into the 3D space. So, but of course, everybody told me that it's impossible. My classmates, everyone I knew told me that how is it possible to just simply have a pencil that can draw into the 3D space, or what kind of an ink can float in the 3D space? So, of course, I was told that it's impossible. I also thought so until uh, one day I remember there was a documentary in the TV, and I saw a group of researchers who used two cameras to do 3D tracking, and they were tracking a flock of birds and scanning them in 3D and reconstructing the whole flock. And then I was thinking that, wow, they can use two cameras to do 3D tracking and 3D scanning, and maybe I also could do the same. So I was thinking that, okay, I want to draw into the three-dimensional space. So how can I solve it? I need a 3D tracking, so I can use cameras, webcams. Usually, that's what I can reach. Other thing that, okay, but what can be tracked? So I had some Christmas tree lights at home, and I was using them as markers, which the cameras can easily see and distinguish from the surroundings. But when I was doing my experiments, of course, I could see the image on the camera, but I also had to create an algorithm that can really do this distinction and figure out the XY coordinates of the Christmas tree light bulbs. Then the other problem was that when I was doing my algorithms and experiments, usually I had to darken the whole room, which is of course not too user friendly. So I was thinking that, okay, how can I solve that with opened windows and with not a dark room, the light bulbs is also could be distinguishable from the surroundings. And luckily, a couple of years before that, there was a full solar eclipse in Hungary, and I still have had some solar eclipse glasses, and I just applied them in front of the cameras as filters, and they could perfectly help me to like the whole surrounding became dark, and the Christmas tree light bulbs became white. So it was very easy after that to distinguish the Christmas tree lights and the surroundings. The next problem is the mathematics, of course. So I had to create a 3D tracking algorithm, a position tracking algorithm, a 3D calibration algorithm for the cameras, and of course these are not part of the curriculum in Hungary in high school. So basically, I had to come up with my own coordinate geometry. It would have been also possible to, to spend I don't know, months to do research and to study the literature. But for me, it turned out to be easier to just come up with my own 3D coordinate geometry and my own functions and algorithms to do all the 3D calculations. So yes, the next challenge was that how to show something in 3D. To tell the truth, this was the easiest part because just one day I remember my brother came home with the newspaper he just bought, and there was an additional extra included a 3D glasses as a gift. So I just used these glasses. I realized that okay, this is red, this is blue. With the red, I cannot see the blue color. With the blue, I cannot see the red color, and how the 3D glasses are working. So I just created fastly some stereo images, and magically they popped out from the screen. So it turned out that I can easily create a 3D effect with the 3D glasses. And the next one was, of course, that if I want to draw into the 3D space, then if you have the pencil and you push the tip of the pencil to the paper, then of course the pencil knows that it has to keep or it has to put there a line or if you use a pencil or a pen, then when the ink should come out when you press the pen and the paper together. But in the 3D space, you have nothing to press the tip of the stylus. So of course I needed a pressing button on the stylus, and I didn't want to develop just for that my own custom electronics. So therefore I just grabbed the mouse, I opened it up, and I used the button from the mouse to have a button on my stylus prototype. And after that, I put it everything together. I just used the laptop as the screen, and here you can see my first prototype. So I applied the Christmas tree light bulbs on the glasses. Therefore, I also had head tracking, and the computer also could calculate that where are my eyes exactly. So it could project the 3D image to the screen from the user's real eyes position. And therefore, it was not just a 3D stereo effect like in the 3D movies, but really a sharp and solid 3D illusion, like the object would become real. You really could bang with your head the object and look around. And with the 3D stylus, you could also immediately interact with the object. And yes, what was my original aim to be able to draw into the 3D space, it also became reality. So this is how the whole device looked like, just a laptop, a screen, the whole image comes out from the screen and you can freely interact with that. So I was crazy happy that finally my dream became true and I can draw into the 3D space as my cars as I imagined them. And also we tried to be cautious that we thought that this can be something interesting, so we applied for a patent. And after that, my teacher at the high school advised me to go to science competitions with this invention. And I went to the national science competition, and then there the jury decided that they send me to the international final to represent the country. And on the international final, it was in 2005. You can imagine 1,447 projects were there, or something like that. And so it was a huge event, and luckily I could win there six first prizes, which is a national record. So no one before or after me did this from Hungary. And yes, when I came back home, well, the media started to attack almost immediately. So it's like all the newspapers, like the television, the radio stations, and everything. Uh, they were asking for interviews and yeah. So basically, I became a celebrity back then in Hungary, which, to tell the truth, this was the part which I liked the least, or I didn't like this part very much. But actually, this was very necessary because we really, or I really wanted to create a real product from this to be able to really give virtual reality to everyone, so that anyone could have a virtual reality device. And and yes, this is also interesting that before the Intel ISF, I didn't even know that what I was doing is called virtual reality. I was just thinking that I'm building a device that can draw into the 3D space, and accidentally it turned out that I just created the cheapest virtual reality device ever. Uh, so yes, the media was very necessary to be able, as a marketing, to be able to really establish our company and start the development. So the next step was, yes, that we have won a couple of governmental grants for the development, and with the family, with my father and with my brother, we established 3D for All Ltd. And we started the development. We gathered a team, a development team, and we started the development of the product, which of course wasn't that easy as we first thought. The first problem was that when I created the first prototype, then my original plan was to make the next step, which with shutter glasses, which worked perfectly with the CRT monitors, the good old CRT monitors. And back then, those were the most popular kind of monitors. And there came the LCD monitor revolution, which is in many aspects was much better than the TF or than the CRT monitors. But for the shutter glasses, it is very necessary to have a high refresh rate visualization, or the monitor should give a very high refresh rate. And actually, the LCD monitors had a very low refresh rate. So basically, all the CRT monitors could perfectly work as 3D monitors, but the LCD monitors not. And this was a huge problem, which we had to solve. And we came up with a new kind of shutter glasses that are darkening only the field of the screen and not the whole field of view. Therefore, it could create a much lower flickering effect, which is much more convenient for the eyes. And for the first time, we could create shutter glasses which can work perfectly with the LCD monitors. And meanwhile, the LCD monitors also became faster and faster. So it turned out that we can have a solution over this issue. After that, the next problem was that is to how to solve the 3D tracking. Of course, I used very cheap web cameras for the tracking. But if we want to do a product which is manufacturable, then we cannot just simply grab the webcams. And also to have a good quality tracking, it is also necessary to synchronize the two cameras, which is webcams are not capable of. And also the frame rate of the webcams is just not enough for a really good position tracking. So we started first to develop our own camera-based tracking solution, but it turned out that if we not just grab some webcams which are manufactured in huge quantities, then the whole solution becomes very expensive. So if you do your custom camera development, back then the end result became just very expensive. So it turned out that we need something fundamentally new, or something very different to be able to meet the original vision and goal. So then I started to think that, okay, but where to look, how to do that, and I just I remember had a meeting with a company who was developing uh, a device which was using line sensors. It was used in the field of manufacturing and the validation of manufacturing technologies. Never mind. But then I remember that, wow, such thing as a line sensor exists. So a line sensor is basically a kind of when we have a camera, then we have pixels in a matrix. When we have a line sensor, then we have only one array of pixels, so one row of pixels. And this is usually used in barcode readers and scanners, and yes, in manufacturing technology as well. And I was thinking whether I can use these line sensors for position tracking. There are many other issues came out. It required also a completely new kind of mathematics, 3D geometry, new inventing new kind of optics, and many other things. But finally, we could solve these issues, and we could come up with a 3D position tracking system, which was magnitudes cheaper than any camera-based solution, but at the same time, very high frame rate, refresh rate, and very. It was also very accurate. So it also saved the project that we could invent this new kind of position tracking. And there came another problem. So it was very, very cool that we had such kind of a technology, but it turned out that one of the best fields to utilize the abilities of this kind of a desktop virtual reality is uh, because we all probably know virtual reality, so you probably have heard of Oculus Rift or Vive, and what the Facebook is also doing right now. So when you put on the helmets and you have this kind of a virtual reality, so that is called immersive virtual reality. Here it was on the field of the desktop virtual reality, so where you don't lose the sight of your environment, so you still see everything. You are just sitting in front of your desktop computer, and the space between you and the desktop computer and the space behind is becoming the virtual reality environment. And it turned out that for this environment, as a working or environment, the 3D modeling is very, very beneficial, so it can be very good for that field. But inside that, the free form modeling, when you can use the free movement of your free hands, it's that maybe that is the field or the scope where it can be used the most. But there was no algorithms that could effectively we could use in the background to solve us this free form modeling challenge. We could use volumetric solutions, but it requires an extreme amount of CPU and memory. So we were sticking to a surface polygon kind of solution, and we invented a real-time polygonal optimization algorithm. And actually, it was also very interesting to see that 3 years after us, the industry leaders are also started to begin to use such kind of an algorithms, and this really helped us to create not just on the hardware side, but also on the software side, a solution uh, that helps us to really use this kind of a technology. And of course, another challenge was that we were we were a company or a team of 9 people, and we had to do the full hardware development. I mean, the mechanical parts, the electronical parts, the optical parts. We also had to develop different kind of applications, some of them for education, for gaming, for 3D modeling. But we also had to develop the whole platform in the background, the SDK and the API, so that also any third parties can develop applications for this kind of a desktop virtual reality environment. And this was actually also very challenging, but we came up with a platform where even plugin applications could be developed. So yes, this also was a big challenge, uh, what we need to answer for. And lat and Finally, the child was born, so we could make the prototype of not just the prototype where you can just draw into the 3D space, but the prototype which is manufacturable, and we could develop the whole manufacturing technology. And so it just became our dream became reality. And here, this video footage is just shows the 3D modeling capabilities of Leonardo. So here, actually, it turned out that for freeform modeling, it became the fastest 3D modeling tool ever existed. So this video footage is actually real time, so it's not accelerated or fast forwarded. It really worked like this, that in just a couple of seconds you could create any kind of figure even faster than you could make a sketch on a paper, because like with your free hands you could immediately work in the 3D space. Yes, and one more click, and here you can see this little dragon mouse head. And later, as we developed the product, or we had the prototype of the product, new acknowledgements and awards are started to come. On the left, you can see Dan Lewin, the vice president of Microsoft. He gave me the Tech Award in the Silicon Valley. It is the Tech Award is probably one of the most prestigious awards in the Valley. VMI gave the best innovation of CES or selected Leonardo as the best innovation on the CES. So CES is the largest consumer electronics show in Las Vegas. The Intelius gave us the International Entrepreneurship Award. Actually, that was on the New York Wall Street Stock Exchange. And also Prince Charles tried Leonardo on the Hungarian Academy of Sciences, of which actually I have a footage that here this is how Prince Charles, who is already King Charles, the King of England. So this is how he was drawing in the 3D space with Leonardo. And the person on the left of Charles, Prince or King Charles or Prince Charles, he is the president of the Hungarian Academy of Sciences. So after the prototypes and these new awards, we could luckily find venture capital to invest into our company, and we raised 5 million euros in investments, which is on an international scale, maybe not doesn't seem extremely high, but in Hungary, actually, that was the largest venture capital fund, and it was their largest investment. And we could start to really gather a bigger group of people, more employees. We had around 30 at the when the company was the biggest, and 20 distributors all around the world. So we started manufacturing and worldwide the sales and marketing. But unfortunately, after a time, it turned out that actually this had many reasons, but one of them is I think that we were ahead of the market. So if you just think about it, even today, virtual reality is not something, not what everyday people use in their lives. So it turned out that Leonardo as a concept at that time wasn't financially sustainable. So we had to split the company to the software department and to the hardware department. The software department is created a spin-off which is called Leopoly, and our former sales marketing manager or director and my brother, they are CTOs in this CEOs, so they are the chief executive officers of in this new company. So the software department is still lives on, but we had to close the hardware department and the concept of Leonardo. And after that, years were passing. I was going back to my university studies, even to my PhD studies, and after that, suddenly I just got a message in LinkedIn from Inhi, our CEO at Parandurumi and founder, that he's building a startup to revolutionize education with desktop VR technology. And of course, I was very interested, and I jumped right into the company, to the project. And it turned out that our former competitor, Zspace, is well, actually, this is this is an US company in the Silicon Valley. They worked with magnitudes higher investment, maybe 10 times more investment, and their product is 20 times more expensive than Leonardo used to be. But still, they started to get traction and sell more and more products in education, and they are also present in Korea. And he was very aware of this, and he knew Zspace, he knew even Leopoly, and he just contacted me on LinkedIn that whether I can help him to make a product which is much more affordable than Zspace, and also not just more affordable, but has I mean, more capabilities and could maybe provide a better quality, even better quality desktop virtual reality. So this is when we started to work on our MVP, and here you can see our first MVP, how it looked like. This was already developed with Parandurumi, and here you can see that no input device is already, and the head tracking could be solved with a simple webcam. So this was really just a first prototype, but already working very well to be able to really provide a full desktop VR for the fragments of the previously for the fragments cost of for much less cost or fragments of the cost of the previously existing devices. And of course, we are working on the new next big thing, and since Leonardo, many years have passed, and the technology has evolved like tremendously. And of course, we want to utilize these new technologies, and artificial intelligence and neural networks just became so smart that on a camera image they can just simply track the bare hand, they can track the head. So without any additional devices, it is very easy to do gesture tracking, real position tracking for the bare hand or any objects, for the eyes, for the head, etc. And right now we are developing and working on to utilize these new uh, artificial intelligence and neural network based technologies to be able to create a new and even better and even more cost effective product. To really our goal is to revolutionize the education this way and to give for the teacher, for the students, such a tool, such a device that can really help them to educate very complex concepts even, and to help this whole process. So this is our Parandurumi, and this is our team. There's a Hungarian branch. Me and Adam, we are working on the development, and there's a Korean branch uh, led by In-hee, who is the CEO and founder of Parandurumi. And in Korea, there's of course they are developing they are developing the business side of the project. So thank you very much for listening, and I hope that very soon. So right now I'm in Hungary, but I hope that very soon we will be able to meet in person.